Learnings from Log4Shell. Applause.
Hi, everyone. So, who remembers Log4Shell anymore? Who was affected? Quite a few. OK. So those who don't remember, we all had Christmas plans because it broke around mid of December, and everybody was like out partying almost, and then we were very busy with Log4Shell and trying to fix it. So just to get an idea what everybody is using for logging, who is using Logback? Who is using Log4j1 still? 1, OK. Log4j2? Who is using something like system out println? 1 or 2, OK. So that's also a common thing. The good thing is if you're using system out println, you're actually very safe. You don't have any of these fancy problems. Yeah, you can do all kind of fancy things there. So I wanted to break this out into 4 parts. What even is Log4Shell? For those of you who don't remember it, how do you exploit it? How can your product be affected? Because we were quite affected by that, and I spent half of my December on that. And then how you can actually protect against that. So I work for Elastic, and our products have used a lot of Log4j too. So I spent a good amount of time on that a year ago. So what was Log4Shell? It kind of started, I think, in a Minecraft ecosystem, and then all the little kids were coming up to their parents and saying, like, what is this Log4j thing, and why do I need to update Minecraft, or why did somebody take over my Minecraft instance? And then you can try to explain to kids what that is, but we don't want to go through all the details. We'll go ahead a bit quicker. So there was this exploit in any current version of Log4j2, and Log4j1. For those who are still using it, it's generally end of life and no more security updates or anything, and it was quite bad. The background was, or is, there is JDD or JDD, depending on how you want to pronounce it, the Java naming and directory interface, that gives you that great feature of your application wants to fetch some remote value, for example, from an LDAP server or an RMI or Corba server. So you can retrieve some value and just look it up at runtime in your application. And at Black Hat, as you can see in the URL, somebody in 2016 looked at that at a big hacker conference and said, this looks interesting. Maybe we can do something with that. And then nothing happened, and it took some time until people figured out, well, this is actually very interesting, and this is really the foundation of Log4Shell is doing, that you could fetch remote values and then not just fetch values, but execute them in the context of your logger. So the news broke that you could exploit something by giving it a value like this, and then it would fetch whatever value from attacker.com and execute whatever you gave it here. So it was a very clean and easy remote code execution because you basically just injected a string like this, and it would fetch whatever you provided here, and then it would run in the context of your application. Full remote code execution, like the worst of what you could get. There is nothing, you don't need to be authenticated in most cases. There is no limitation to that. So to see or how to think of that in a more graphical way, you have your logger and your application is logging, and then you have the appender that writes it out, and that uses a layout how to format your logs. So that might be XML or whatever else you have to format that. And Log4j has this great thing where it has lookup plugins where you have a key, a name and a key, and you can actually look up a value, which might be very helpful if you, for example, want to include the Java version in your log and say, I'm using this specific Java version, and it just looks it up at runtime. So that sounds kind of helpful. And then you can combine that with the JDD lookup, which can look up some value from a remote system, like, I don't know, my application name or whatever else you want to have. And then the problem was that the JDD LDAP lookup is you can go inject that value, it will look it up from a bad LDAP server, and then execute whatever it gets back here. And that is exactly how an attacker can exploit your application. It basically gives it a link to a bad or a server under their control to give it whatever code they want to execute, and that's all you need to take over the application. Simple, straightforward, not fun if you have it. However, we could always be a bit more positive and not call it arbitrary code execution, but it's like a surprise extension API, because that's really what we have with LDAP, that you suddenly can do new things that you were not expecting before. And then there's the discussion, is this a remote code execution or is it more a serialization issue? Because you're fetching some remote value and then it gets deserialized and you actually execute it. And depending on what JDK version you're using, there are some protections in place, but then you just need to swap out the LDAP attack vector and you can still execute code. So there's something in more modern JDK versions that it doesn't actually execute the code from a remote URL by default, but there are other ways to work around that. So it's still fully exploitable in most scenarios. And then just as a pointer to this CVSS score is always the list of like how bad is the vulnerability, and it can go up to 10. And it basically is like, what does the attacker need to do, and what is the result of what they can exploit. So the solution was then to upgrade Log4j. And the thing with Log4j is it still supports JDK 7, and then you're on 2.12, and all other versions keep moving forward. And so there was 2.15, but don't use that because that's also vulnerable, and then there was 2.16 and 2.17, and we'll get into those in a moment. So I guess everybody knows little Bobby tables, how you could name your kids, and this is little Jindy tables. So if you name your son Jindy LDAP Evil Corp Bobby, then you could probably take over the school system if they're using Java. So that's what you could do in various attack vectors. Side note, because we have been affected by that, who is using a security scanner to find vulnerabilities in their code? How successful are they? Medium often, right? Or at least in our case, we get a lot of false positives because there are quite a few trade-offs around this of how you could mitigate this vulnerability, but most of them are very bad at looking at the mitigations or figuring out if this is actually exploitable or not. So we had a lot of false positives. So for example, one way to fix this vulnerability, if you, since it's going through this Jindy lookup, you could just remove the Jindy lookup class from your jar, and then you're not vulnerable anymore, because you basically close the door or the attack vector. But no security scan, or most security scanners don't actually figure that out. And it depends on the JDK version that you run, and then there are some settings that you could set that you don't do or don't allow lookups in Log4j. So all of those would protect you, but most security scanners don't find you and just give you random reports. So we had one Log4j issue, but there can always be more, right? It's like the hobbits that always want to have another meal. So people started looking at Log4j, and what they found was that the first patch was incomplete. And at first it looked like it was a denial of service attack, but then they found it was actually, again, a remote code execution, because what you could do is you had to change the attack vector from this to that, because the first patch thought that this is a local lookup, but this would then be ignored, and you could still fetch something from attacker.com. You just had to swap out that string, and that was still how the remote code execution worked. So don't use the first patch, use the second patch. It did depend on a non-default pattern for logging, where you had something like this, where you had an explicit input where like tainted, and you could add that. But that was still kind of common, so it was still a problem for that. So you could upgrade, or again, you could remove the JNDI lookup class, because that's again closing the entire attack vector of lookups. So while it's a dumb fix, it actually does help, and that's, for example, what we did in our products. Like, we are, to this day, we're removing a JNDI lookup, because who is using JNDI lookup in their loggers? Nobody. So why is the feature even there? That's why we are just removing that of any Log4j version by now, and it fixes the entire issue. And then we had another Log4j issue, because people kept looking. So this one actually was only a denial of service attack if you used a non-default pattern. So you could upgrade that, but not such a big deal anymore. And basically what they removed was recursive substitutions, because that's, again, in theory, a great feature in a logger to have, but who is doing recursive substitutions in their logger? And it just triggered a new class of attacks that was really unnecessary. And then, finally, the fourth issue that was found You could have a remote code execution via the JDBC appender if somebody controls the configuration file, which led to the discussion, how much of an attack is it if the attacker needs to be able to control the configuration file on your server? But some people were like, well, it's still a remote code execution even if you have this precondition. So to actually exploit this one, you need to wait until an insider is changing the configuration file the right way for you to exploit. So this one is probably not such a big deal anymore. The first one was, the other ones were like more nuisances or funny gadgets. Which leads us kind of like to the point is like, how many features do your loggers need? Because all of these features are kind of like used by less than 1% of the users of Log4j, I guess, and they cause the trouble for everybody. So all of these features keep coming back at you. It's a bit like OpenSSL, which was Heartbleed. That attack, I think, was also, like, it was a very obscure feature that caused this entire security issue, and it's often like these small things that somebody thought is a good idea at some point, and then everybody forgets about, until somebody starts looking and finds out that this is a full remote code execution. Or in the case of Heartbleed, like something to exfiltrate all the data. And the people who found the initial Log4Shell vulnerability made the first logo, and every time they found a new security issue, they made the logo worse. So this is the logo that people ended up with. And if there is another one, it will get even worse. So this is the final logo of Log4Shell. So how can you exploit it? I'm using a Spring Boot application. What is the default logger of Spring Boot? Logback. So we actually need to change it to use Log4j, otherwise your Spring Boot applications by default wouldn't be affected because Logback. But here we have a project that is using Log4j as a logger in a vulnerable version, so we can actually have some fun. And then all you need to do is to be exploitable, we define our logger, and then we log something, for example, a header. So XAPI version is the header that I want to log here. And then all an attacker needs to do is know that you log this header and then kind of like push in the bad string to resolve whatever remote value you want to have. So what you then need to do is you need to run your LDAP server from where you can fetch the payload or the malware that you want to run. Then you run a request against the vulnerable application, and here I provide that API version header. And I say like fetch from my LDAP server from above, fetch whatever I have base 64 decoded here, fetch that piece of code, and then it will run in the context of my Spring Boot application, and you're fully exploitable. That's all that you need here. At first, people were a bit concerned that there would be a virus or worm around this. That didn't happen. Why? Because it's so application specific. The attack vector relies on that you, for example, this application is using or is logging this specific value. Or another application is logging the user agent or whatever other values you want to log. So it's application specific. That's why it was very hard to write a generic attack vector or worm around it. That's why at first people were worried about that, but that didn't happen. It's more for targeted attacks of your application. How can it affect your products? Like I said, I spent a lot of time in December on that. So in Elasticsearch, for example, we have Log4j forever. And basically, we had it from 5.0, which came out like 6 years ago or so almost, to the latest version last December. We had vulnerable Log4j versions. But it's actually not that simple. And I'll show you why. So you need this full matrix of, this is the Elasticsearch version, this is the Log4j version that we're shipping with it, this is the JDK that you have, and then depending on that, it allows a remote code execution, an information leak, and what you need to do or what you don't need to do. So before the new patched Log4j version came out, what actually saved us in Elasticsearch was we're using the Java Security Manager. Is anybody using the Java Security Manager? No, exactly. So I guess for the standard web project, it's probably not the right trade-off, or it's a bit hard to use. But if you have a widely used library or tool, it can totally help you. So what the Java Security Manager is, for example, doing in our application is that the logger cannot do a network call. because it doesn't have to. So it can never fetch code remotely. And only in old versions with a specific JDK combination, it could do DNS lookups, so it could potentially exfiltrate some information from the server, but it couldn't fetch any code or execute any code. And then we patched Log4j. We removed this JNDI lookup class. We just removed that from the jar. And we also set another value, the Log4j format message lookups, no lookups true. So it doesn't actually resolve any values. So we do all of these. This already fixes it, but because of the security scanners that keep shouting, we have also updated the Log4j version to the latest version at some point. For version 6, that was still supported back then, the picture is very similar. For version 5, which was not supported at that time anymore, it looked a bit different, because here the Java Security Manager wasn't as strict, so the logger could fetch remote values and actually be exploitable. And if you were using an even older version, which is really bad, but you were safe from this one because it's still using Log4j1. So it's kind of like once your application is outdated enough, it might even be too outdated for the exploits. So sometimes this saves you, but I wouldn't rely on that. And then the question is like, do you know in all your dependencies what Log4j version they're shipping and what Java version they have, especially if it's running in a Docker container? And probably nobody does that with their entire application infrastructure anymore. So we have been shipping the JDK with Elasticsearch in general, and in Docker since a long time. You can check that version, and then you can also see if that makes you vulnerable. Also, speaking of the Java Security Manager, it really helped us here. And we're, I think, one of the few projects that actually uses the Java Security Manager. Unfortunately, it is deprecated by now and will go away. We're kind of sad about that because it helped us a lot. On the other hand, if nobody is using a feature, what good is it doing? Like, is it really solving an issue? So we'll see. I once got the question like, how much of a pain is it to add the Java Security Manager? And I can say it was a lot of pain, and we had people work for not only on that, but for multiple major versions on getting the Security Manager packaged up the right way. Because basically you need to structure your code that some types of access, for example, are only happening in specific classes or packages. And then you give only those packages or classes some access or some permissions, and do not allow the rest of the code to do that. So for example, what we have in our security policy, that's the policy for the Java Security Manager, everywhere in the code, we can do a DNS lookup, and then we can only set some options, but we do not allow opening a network connection. And only in very few places we give that socket permission. So if you search through our code base, you need to search for socket permission. That's only allowed in very few places where, for example, Netty is working and establishing the network connection. Since Netty is doing our network connections, only there is our code allowed to do a network call, but not the logger. And Elasticsearch 5, our rules were not as strict yet because then we had that problem of security issues. How are we going to replace the security manager? Who is using JPMS? Okay, it's kind of like a similar picture. We are refactoring all our code now to use JPMS to modularize it, and then only now allow certain things on a per module basis. So we have a meta issue, and I think we're about halfway done by now or so. So we are breaking up all our code into the different JPMS models to have some security boundary, what to allow where. So even if there is a vulnerability in one part of the code, it hopefully cannot take over the entire server, or it doesn't need some permissions, so it adds some layers of protection. That's what we have here. And the other thing that was kind of ironic, that we had a very long-standing issue to update Log4j because we were using an old version, and we never managed to do that because the newer versions of Log4j didn't work well with the Java Security Manager. So we were kind of blocked by that. But then the latest versions are working with the Java Security Manager again, and we could update. So sometimes the Security Manager is helping you, and sometimes it's making it much harder. So since almost nobody is using the Java Security Manager, is probably not the right tool anymore, though it can be helpful sometimes. The other things that you can do, like what we are doing, is we always set this format message no lookups to true, so it doesn't allow any lookups. You can actually query that from the API and would see all the JVM parameters that when you start an Elasticsearch process, if they are set, which can be very helpful to debug that. And we're setting that on any service that we run, for example, or in any binary that you run nowadays. I also said that we are removing the JNDI lookup class. This is the Gradle build part that actually removes that JNDI lookup class from any Log4j when we build it. So we actually just take the default Log4j dependency, but in our build kick out this class because we don't use it and don't need it. And any Elasticsearch binary that you download nowadays has this class removed by Gradle. If you're using an older version and want to do that manually, you can do that, since a jar file is only a zip file in the end, with zip. So this would be the command to actually remove that JNDI lookup class from a jar file. And this way you could check if there is nothing with JNDI lookup in a jar file. So even if you don't get updates for some old products, you could still mitigate the security issue by just kicking out the JNDI lookup class and basically closing the attack vector like that. Which is not a great way to do it, but it's a hack that works, and normally it doesn't affect anybody in production. There was also a hot patch from Amazon. They're having their Corretto JDK distribution, and they had a hot patch for that, which basically allowed you at runtime to fix the problem and close it. You had to, or you have to apply that at runtime every time you start the JVM process though. What was kind of like ironic was that they also had a security issue then, which only broke in April, and then the hot patch got a hot patch to fix the security issues there. So everything around this was full of security issues, and this took like 4 or 5 months until somebody found this. But it was eventually fixed, so even if you're using the hot patch and in the latest version, then you're secure again now. By the way, don't try to be too smart. I have seen the recommendation where people say like, we'll just disable all the logs, which you can do, but that's maybe not the point. So for example, in Elasticsearch, what you could do is we have a cluster-wide setting where you can say like, on the root level, just disable all logging, but then you just don't see any logs anymore. So even if your process doesn't boot up correctly, there will be no logs and you will be totally stuck. So don't do that, but people try to be smart and try something like this. We've also seen people kind of like YOLO replacing jars, and that's, at least in Elasticsearch, is a really bad idea because of the Java Security Manager and like the expectations that we have, like we call them bootstrap checks. The process will probably not start up. So don't do that. Maybe replace or remove the JNDI lookup class, but don't just replace full jars because that will just break your entire server. And we had multiple people full-time just answering Log4j questions at some point in December because every customer was panicking and asked for an update now and for whatever weird combination of things they were trying to do. So how can you protect against that? Somebody made this very helpful chart which starts with, I am running code in the JVM. Because the panic was so large that people even not on the JVM started worrying about Log4j, which is a bit ridiculous, but it is what people do. And then you say no, and then it's still a question like, do you have any third-party solutions running in the JVM? Because then you might be vulnerable again. Is everything marked as safe? Then you're done. So if you have something running on the JVM, then you need to grab like, what are the loggers that we're using? And then you can figure out like, am I affected or not? And then you can check, what is the Log4j version? What is my Java version? And then you can work your way through here, and at the end you will figure out, are you vulnerable or not? Which is quite a cumbersome process, and obviously people freaked out because of that. By the way, if you're still using Log4j 1, they had a bit of a drama because they don't release new versions anymore. And then the original author of that forked it under Reload4j, so that's Log4j 1 with some more security patches. So if you're very stuck on Log4j 1, this might be the best place to go. Otherwise, you should still try to get off Log4j 1 because it has some concurrency and performance issues that are pretty much unresolvable, so you will need to find a way out of that. And then when I said panic, people were writing to Daniel Stenberg. He's the main guy behind curl. What is the language of curl? C or C++ or whatever, yeah. And like he got emails that saying like, respond within 24 hours if you're affected by Log4j, which is kind of ridiculous, but people were just pushing off like the blame to everybody else, or were just panicking and asking for stuff. So even he had a lot of fun, like people using the JVM like us had a lot more fun around this with all kinds of weird questions. Two things that sometimes people get kind of like wrong or are a bit confused is you don't need to use a vulnerable version in your app of Log4j. For example, if you're logging and your logging provider uses a vulnerable Log4j version, that might be enough to affect you. And that application in the background is enough. It doesn't need to be direct network access to the thing. As long as you can kind of like get the tag string to the vulnerable system, that's enough. It doesn't need to be directly exposed. As always, sanitize your inputs. And in this case, an outgoing firewall, for example, would have been nice, so you cannot load remote code from some random place. So to make this a bit more graphical, you could block weird requests with the web application firewall. For example, anything that starts with $, curly brace, JDD is probably not a normal string that you're getting, so you could just throw that away. You should definitely patch Log4j if you can. You can disable those JNDI lookups, or you could, for example, do something like the Java Security Manager where you disable loading code remotely. So all of these help to fix this. We have actually, and now let's see how good the Wi-Fi is. We actually have 3 honeypots running here. So we have been running this since December, and you can see there was a peak of exploitation attempts back then. But there was even very recently, end of or early September, there were quite a few attack attempts. So we've seen like 1,500 or so exploitation attempts on our 3 honeypots, which are in London, New York, and Belgium. And you can see where the attacks are coming from approximately. And these are some of the attack vectors that people are using. So you can see here, the user agent is often used to throw whatever weird combination of these JNDI lookups into your application, because many people are actually logging the user agent. And then we have like, these are 3 target servers or honeypots, and you can see wherever the different requests are coming from and what are IP addresses that are scanning from. Surprisingly enough, the last few attacks were all coming from Switzerland, which is a bit uncommon, but there are other regions that are making a bit more sense maybe. And well, we've been just logging all of these, and it's still like an ongoing attack that people are trying to exploit here. If you want to, you can access that actually. It's Log4Shell thread search IO, where we run this as a honeypot, or like show the results on our honeypot, and there you can just see how people are trying to exploit that. The problem is, since these are logs, and we might have remote code execution in our logs, it's kind of like a stupid catch-all problem, and we wanted to look like, how can we actually figure out if we have been exploited or not? So what we have done is, we put together some of our tools. So we have a Spring Boot application that is vulnerable, and we're just monitoring that and logging all the attack vectors. And what some of these might look like, for example, we have a seam which basically has rules built in that detects weird stuff in your events, and that would see, and it's a bit hard to see, but at the bottom down here, these here are the ones that are relevant. So our Java process spawned the child process, and then we had some malware being downloaded onto our node. So that's a weird sign, and that's like one of the signals that we can pick up. We could also see, looking at that flow of information on what host, by what user, what was run, the commands, that were happening. So for example, you can see here somebody downloaded some Mozilla A binary onto our server and then tried to exploit that, which in a graphical way could look something like this. We have our Java process running, that spawns a shell, that spawns another shell, and then that calls wget to fetch whatever binary. That is probably not what your average Java process is doing. So this is, if you find something like this in the call stacks or the call hierarchies of your applications, that's a weird sign to figure out that something is going wrong. And we we basically have rules to find stuff like that. We call it like an uncommon child process that finds some stuff like that. You could, for example, also see what you're running on that host then, and then you see, oh, we're actually running a vulnerable Java application there, and then you could figure out, okay, this was probably Log4Shell. Or you could, for example, if you're using OS Query, is anybody using OS Query? It's like a tool that collects information about hosts, and then you have an SQL-like query language to query information out of that. So what this is doing, it's looking for jars that have Log4j in the name, and then you could find like, oh, this application here is using a vulnerable Log4j version. So we can then look through all our hosts, for example, to see who has a vulnerable Log4j version deployed on their hosts. And then if you use anything like tracing, you could see this is your application, and suddenly it starts to do weird network calls, which is also maybe not common from your application. And then in the trace detail, you see this was actually the header, the XAPI version that I've shown you before, where somebody injected whatever weird value to exploit that came in. And then in the call history, you can also, or in the call stack, you can see something was happening here in Log4j that looks very weird, and you have all the usual suspects. I think you have somewhere in here, you have the JDD lookup. So here, yeah, here you have the JDD lookup. These are things that probably are not very common in your application, and you could just, for example, search through all your stack traces to see, did anything access JDD lookup in my application? Because I don't use it myself, so this should never actually be triggered. And then if you see in your network overview, you have your application that suddenly reaches out to some random host that you have never seen before. Those are also signs that something is off. So hopefully we turned this around, and then we kind of stopped Log4j. So to wrap up, all of this is a major mess. And it's probably still lurking somewhere in your infrastructure, because nobody remembers all the services that you're running somewhere, and it's just like sitting there and waiting to be exploited. Especially since Java has long been having this advertising of like running on 3 billion devices, and some people, this kind of like creates nightmares, where your brain is saying like, Log4j on your toaster, and then you think, well, that's not true. And then you're like, well, let me better Google that. If I might have Java and Log4j on my toaster. It was, in the end, one major vulnerability that caused all the issue. The 3 follow-ups were more like noise, where others who found those tried to capitalize that and get some attention. But the first one was really the main problem and what caused all of the friction. But yeah, December was a rough month for quite a few of us. Hopefully not too bad. And in theory, it's easy to exploit. In reality, it's a bit more complex, because it depends on the Java version, and then if you have the security manager, and all of these things. So while in theory it's a very simple exploit, in practice it can sometimes be a bit harder to get right. Sometimes I get asked, like, is this still a problem? Like, aren't we done? Like, it's almost a year. And it's totally not the case. So for example, this was in June, where I think the US Coast Guard, Cyber Command, whatever, they saw new exploitation attempts, especially for more targeted attacks. Like the attackers, once they're in a network, they look for Log4j or Log4Shell very specifically, because it's probably still sitting somewhere, and it's just like the next step in many networks when they try to exploit them. So it's a problem that is not going away anytime soon, and it will probably be lurking in our infrastructure here or there. With that, any questions? Was anybody exploited, or do you not, or nobody wants to admit that? Or nobody knows? Yes, that's the other problem. Yes.
Hello, testing. How prevalent was the issue with your clients? I mean, did you actually saw some losses because of that?
So, I must say that very few organizations have admitted how they were exploited. I feel like there are often like these, like somebody was ransomed for whatever reason, but they never tell you why. So I don't have a good grasp of like how often was it like social engineering or Log4Shell, but I'm pretty sure some were taken over by Log4Shell. And I mean, at first, I think the first attack wave were more like the script kiddies throwing parameters at random servers to see what happened. But there's this long tail where more targeted attacks are trying to find somewhere you have a vulnerable server and then you bootstrap off of that. So I think that's a bigger thing that will keep us busy. But I haven't seen a lot of people admitting that they were exploited, to be honest, or not by that. It's always like, oh, something happened, and then you always hear this explanation that, oh, it was something very sophisticated that nobody could have foreseen, and it was totally not our fault. And then you know it was something simple.
And then it was Log4j on a toaster. Thank you so much, Philipp.
Thank you.